You tell it, Rob.
Didn't do it automatically.
No, it's actually bedtime.
It's actually bedtime.
Yeah, it's actually bedtime.
You got to go, Joe.
Yep. See ya.
Good night. Have a good night. Thanks for joining the podcast, everybody. It's a real short one today.
Wait, don't go away. Don't go away.
We're kidding.
Yeah,
Turn it off.
something like that.
Turn it off and go say goodnight.
The what do you call it? But yeah, this is actually one of MXR's things. We got the little panda thing, and
Is that the pin or is that a sewn on?
no, that's sewn on.
Okay.
The pin was like the Crusade shield or whatever.
Yeah. Did you get?
That's
you got
actually
one
on the
those,
back of
didn't
the
you?
hoodie that I'd have to turn around, and that would be like really annoying with this background. It would like, yeah,
We're good.
but whatever. Anyway, yeah, it's really comfy. I like it. It's good. Goodbye. No, not goodbye. Like it's a good
B-U-Y.
purchase. Good purchase. Yeah, there you go. Good
Y'all keep just
Anyway.
trying to end this podcast.
Yeah, I
off
know,
the
right?
bat.
I was all like, I got things to do. Let's go. But anyway, you were saying about the shirt there, Mr. Speed Cube.
About my shirt.
Yes.
Yeah. So
Pretty cool. It's
For one-
melting.
I do like it.
for one thing, apparently I found out recently, I think Sheldon on Big Bang Theory wore it, but like, who gives a fuck about that? So maybe I should get closer. Like it's actually incorrect. It's an example of like an incorrect cube. So basically because of this corner here, this white, yellow,
Yeah.
and orange corner, and this one right here,
It's not white.
well, you just
No.
can't see the other sticker, but because of the way the yellow and the orange are like flipped, that means if you were to put this one in the spot, it would be the same ordering of the yellow and orange. So it would effectively have to be in the same spot on the cube. And so it's basically the same piece twice. So it wouldn't be able to exist.
Yeah, but I'm like, I guess everything can be stickered differently, right?
Right. So basically like if you have a cube here, like,
Yeah, because I mean, if I look at mine, like there is no white and yellow, like that
Well,
will never happen.
yeah. So this
Yellow and
is
orange. Yeah.
This is for one thing, it is a weird color coding. There are like, it's more similar to the Japanese style, but it's not even that one. It's like its own thing. It's totally just not it's an impossible cube. But basically you would expect the other piece to be like yellow on the same side. You see how they're like flipped, yellow and orange?
Yeah, that's yeah.
You would expect it to be yellow up here and orange down here, but because it's flipped, if you were to put it in that, it basically is the same piece. You could
It
infer
would
that
always
should
be
be a white.
wrong. It would never be a right.
Yeah. You would never be able to get it back to a solved position because it's got like a duplicate piece here, basically.
Which it's
There's
also
a couple-
it could never be in a solved position.
Yeah.
Yeah, exactly. Yeah.
Well,
There's-
that's like the thing. Like when you get the cube, when you buy them, they're set, like they're correct.
Yeah. Well, they have stickerless ones now. These are like the new fad kind of, the new standard almost. Like you see, it doesn't have stickers.
So it's
The
just colored plastic. Yeah.
Yeah, the plastic is colored.
Mhm.
So
But I mean, I've never seen one like in a packaging that wasn't solved already, you know?
yeah,
I think
yeah.
that's intentional.
That would be cruel. That would be
Yeah.
very cruel. Although there is something called
Well,
like
you
the-
want to know it is solvable.
Solvable, right? Exactly. That's what I'm getting at. Like, if you didn't know, if you couldn't see that it was all together in its original
Good night.
packaging, then like, if you couldn't solve one, you could easily be like, well, this is unsolvable because
there
you
is
don't know.
there is something called the Rubik Impossible. It's like a 3x3, but it has like the lenticular, like, so they're like hologram kind of like stickers, so that like if you look at them from one angle, it'll look like it's solved when you have it solved, but if you look at it from another angle, it just looks totally mixed up. And so if you have to be looking at all, once you mix it up, they're all like facing every which way, so you have to be looking at the
Wow.
right piece from the right angle. It's like incredibly more difficult. If
I
you
would
Google,
imagine.
yeah, it's hard to tell in images of it what it actually does, but it's like if you ever looked at those images of like, if it's like a lion's head and you like move your head around and it like looks like the lion's head is like moving around, it's like that kind of thing, but it's like two different colors for each tile, each sticker, but they're not stickers on that Rubik's Cube. The Rubik's Impossible. So each one is like the right color and a wrong color. And if you look at it from the Rubik's Impossible puzzle. It's like the texture of the plastic that those lenticular images are usually on is like, they're like parallel lines, you know, they usually have like a texture.
Okay.
Joe's out.
Oh, he just, okay.
Something happened.
Paste. All right. Is that okay? Cool. So it's still.
He saw the Rubik's Impossible and he just dipped. He's like, oh, I can't do this.
Apparently. He's totally gone. He's totally gone. He's totally gone. Okay.
Sorry, guys.
Oh, there he is. What happened? All this Rubik's Cubes talk starting to bore the crap out of you?
No. Yeah, I had to take a nap, you know. No.
Yeah.
So I think I've actually seen this before. I think probably you mentioned this before and I've looked it up.
Maybe.
Yeah, it's really interesting, like, because I do want to get a better one of these, because this is like, I literally bought this in the checkout line at freaking Micro Center when I just happened to see it, and I was like, oh, okay, cool. But yeah, it's really cheap. It turns so easy. Like I barely touch it and it moves. And I'm just like, ah.
Can you
So, getting violent with it doesn't work.
Can you like pop the center caps off?
I don't think they're center caps.
They
They're
might
just-
be.
they're
You might have to.
stickers.
No, like even the like stickered cubes, a lot of them you can probably take the center cap off if you like see the seam under the centerpiece. There's probably like, it's probably like white plastic centerpiece. Because I have one kind of like yours. It's over on the other side of the room.
No,
but
these look like solid pieces.
What's that one in your
'Cause I
background?
don't know if you can see the
Um,
corner of it, but oh shit.
not the smaller one, the bigger one. Yeah.
This is a
It's still not working
6x6.
with the thing.
So it's
Dear
just a
God.
normal 6x6, but I have a pattern put into it. The
Yeah.
cube and a cube and a cube pattern.
Which is pretty cool.
Yeah. There's the other side.
How long does it take you to do one of those?
Like 30 seconds, not too long. I mean, this cube is not very good, so like the actual turnability of it is not very good, so it takes longer for that reason. Similar to yours, you know, once you get any speed cube, your time will go down by like 5 seconds right off the bat.
The magnetic feature stuff and
Have
you were
seen
talking
this,
about. Yeah. Oh, wow.
It's 4x4.
Checkerboard.
Yeah.
Have you seen this ball with like gears in it? It's different colored. It came
Ball
up
with
on
gears.
and when I searched Rubik's Impossible and then went to the images.
Oh yeah, I
up
think
as
I've
one
seen
of
those
them.
before. They're That's I think the ball ones we were talking about before, and then it was the
Oh yeah. They sell those in Walmart sometimes. They've got so many different types of cubes, though. Your mind would be blown with all the different cubes and then shape mods of cubes. Like there are some that look like bananas and oranges and bunny rabbits and stuff, and they're really just like a 2x2 or a 3x3 in disguise. Yeah, there's all kinds of.
Do you end up using like the same algorithms and stuff to solve them, or?
For like the 3x3 shape mods and stuff, yeah, only for those you'll have like interesting instances where the centerpiece will be like a funny shape, so it has to be like facing the right direction, the actual centerpiece, where normally you don't care about that.
Because the way
Yeah.
I figured, like the way I learned to do these, like I guess is probably not the fastest way at all, but it was basically like start with the center, right? And then you wanted to put all the yellow and
daisy.
white. Yeah, the daisy. Yeah, there you go. Yeah, it's like thing is just, it's not going to show it. but yeah, then you like flip them upside down, and then you start figuring out the bottom, getting all the white done, and then you just go row by row. But it's interesting to me because like I don't know if I ever like would have considered until like I actually was like, okay, let me learn how to do this. But I didn't really ever think of like doing it like layer by layer, you know?
Yeah,
So it's like, oh, the face and then the other face and the other face. It's like, yeah, okay, well, no. I mean, you still technically have 6 things, but when you think about it in layers, it does make a whole lot more sense.
absolutely. There are other methods too. Like there's one called the corners first method where you solve all of the 8 corners first, and then you do the edges, which is almost the kind of inverse of what you do with the beginner's method or the CFOP method. Those are 2 different methods, but they're very similar. You do the edges first, kind of, and then do the corners to a degree. You, but yeah,
Yeah, I'm sure as I get more into it and maybe get another, oh, definitely get a sturdier cube that doesn't like literally flop around when I like tap it.
yeah,
The if I try to start actually trying to get, but it's nice to know that I can actually solve one. Like, okay, fat. Like I think, as like I still haven't actually sat down and timed myself because I think it's kind of dumb with this cube and how crap it is. But I'm like around like 4.5 minutes, I guess. Just basically like looking at the clock and then glancing back at the clock when I'm done, you know.
yeah. So yeah, you'll get way faster too. Especially just learning like a few more algorithms. It can
Yeah.
really like help you to understand a few more cases that'll really help you shave off that time.
Yeah, it's like even doing it the beginner's way, getting the first 2 layers is pretty quick. And then depending on how the top layer ends up being aligned when you get to that point, it's like, okay, the way I know is pretty freaking slow. So
Yeah,
because I mean basically you're just doing like there's uh there's a way of doing it, whatever, but I mean it's literally I think 1, 2, 3. I don't know, I think it's like 14 steps to align the corners, right? As you go around the top. But it might, yeah, I think it's 12 or 14. I can't remember right now, but of like different movements and stuff. And then if that doesn't line up, and it's like, okay, do it again. But if like you paid attention to it and you did it the opposite way, like you can go clockwise and counterclockwise depending on where they fall or which way you're trying to move them. So
and you're probably doing the one like you said that's like 2 adjacent corners, swaps 2 adjacent corners.
yeah, like once because you do these 2, god damn it.
Invisible cube.
Yeah, you do the these 2 layers, right? And then you got the top one. So then you're doing the cross whatever with the yellows, and then you're solving the yellow. And then depending on how these side ones fall, like because they should be like this one, it would be the only one that doesn't match at that point, or should be for before the final step. But if you have like 2, say I had 2 greens here and 1 blue, and then the other side, like maybe only one of them like matched up the corners, then there's a long step to rearrange all that.
But so maybe I'm wondering if the algorithm you use is the one that does it swaps just 2 corners. It'll also do 2 edges, but like you're only worried about the corners there. There's one that does 2 adjacent ones, and then there's one that does 2 opposite ones. So like these.
Yeah,
2.
it's definitely, I think it's definitely the adjacent ones.
So yeah, if you learned like the one that's the opposite ones, then you wouldn't have to do that one multiple times. You would either be like, it's the adjacent case, it's this algorithm, or it's the opposite case, so it's this algorithm, and then you're on to the next step.
I don't know enough of them by heart yet to where I'm just like, okay, it's this. Let me do this one. You know, I'm just following my steps.
Yeah, I think the one you probably use is actually a T-perm in disguise, which is like a T permutation. It's like the name of the algorithm, you know, or the case that you would encounter to solve that.
I'm like, if someone threw me a damn cube and was all like, here, I make you bet you can't solve this, I'll be like, bullshit. I can solve it and I can do it in your lifetime. I'm like, yeah, I don't know. Because I mean, I've stayed away from it for the longest time. And I don't know why. I'm like, it literally took me an hour to figure out what I'm using now. So But yeah, I don't know. Interesting stuff.
Yeah.
Anyway, welcome to Technically Incorrect, everybody. I'm Rob, and wait, I gotta look at the other screen. Joe, nope, Joe's over here. Joe, and I said
Right
Joe,
here.
and Scott waved.
I was
Scott.
I was excited. I was ready. I was ready for it.
Thanks for joining us again. And we have, what are we talking about today? Kinetic catapults, yes?
As opposed to static catapults.
Yes,
What would that be?
because yeah, I probably definitely should not have said that. Damn it.
Hmm.
Oh,
Yeah.
But no, we
Go
have kinetic energy launchers for satellites or rockets now, I guess, containing satellites.
Yeah. Sorry, I'm a little distracted because apparently there's an asteroid that's like kind of nearing approach. I don't know if y'all have seen anything about this. Like a week ago,
Go ahead,
I'm
give
seeing
me names.
articles. Nereus. That's kind of funny. It's getting near us, and it's
Yes.
called Nereus. It's Nereus.
Kind of a little bit cringe there.
Sorry, that's me.
No, I'm like that's not good foreshadowing. We'll say that it's not good foreshadowing.
Yeah.
It's as
but-
big as the Eiffel Tower, apparently.
Wow. Yeah, and it was like discovered in 1988, which is interesting. But it's getting
asteroid was?
yeah, but it's getting really close, like right
Apparently
around.
1 hour ago, you could see it.
Huh. Cool.
So when
Yeah,
do we
today
when do
is
we
like
send the
it's-
nukes up?
What?
When do we send the nukes up to try to change its trajectory?
No, we're good. We're fine. The thing about this is like we are aware of it. It's one of the bigger ones. It's easier to spot, although it kind of is in that range that like if we didn't spot it and it did hit us, it could be pretty destructive being the size of the Eiffel Tower. But
Yeah. I thought you were gonna like give us like some really bad news all of a sudden, like oh,
No.
we have 2 weeks to live.
nah, that if anything, this is like a success story that we are aware of this. We can spot this in the sky.
Yeah, but even if we were, I mean, even if we were aware of it, if we knew it was going to hit us, like, okay,
Yeah, would we actually do something about it? It's
like then
there-
what?
Yeah, there have been like groups in the government, and there are like researchers that are studying kind of anti meteor strike kind of measures.
Do we just shoot nukes at it and hopefully try to send it off course, or do
That's
we pull an Armageddon and like go and land on it and stuff?
The nuke idea is a terrible idea because it would break it up into a bunch of tiny little ones, and it might not do it well enough to be less destructive. Like it might not break them into bits that would all burn up. Some might be big, and now you just got a bunch of smaller but still big chunks hurling at the earth, and also maybe some fallout like radiation from the explosion.
Why do you have to overthink everything? Huh? Why?
I'm sorry.
Why? You and your logic. Damn it.
All this to say we're fine. We're fine.
Yeah. Don't worry, we're not gonna die. Don't go and raid Walmart and buy out everything you possibly don't do that.
Yeah, we
There will
all
be
need
toilet paper in 2 weeks.
You beat me to it. But yeah, so this whole SpinLaunch thing.
Yes, SpinLaunch. That's what I was trying to remember. I have since pulled the article back up because I couldn't remember the name of the damn thing. So
it literally says what it is, what it does.
Yeah,
How could
exactly.
you not remember the name? It's
a great big vacuum centrifuge thing that propels shit at 5,000 miles an hour.
yeah. It spin, it
Or is
launch.
kilometers? 5 miles per hour, 5,000 miles per hour.
Yeah, like multiple times the speed of sound is basically the aim there.
So I found it funny that the beginning of this article was all like, SpaceX look out kind of thing.
Oh yeah.
And then obviously it started literally, I'm just going to read the little excerpt here from it. It's talking about SpaceX. Their rockets can carry more for less and soon could even take us to Mars. Are they talking about people? Because I guarantee you're not putting a person in a freaking centrifuge that's spinning 5,000 miles an hour, shooting the fuck out of it.
Sorry,
So,
what was the quote again?
I was wondering if they were talking about when they were referring to SpaceX. It says their rockets can carry more for less and soon can even take us to Mars.
But that's SpaceX rockets, not the centrifuge.
Right. Yeah, I know. But were they talking about just taking like a probe or something, or stuff, or actual people?
For SpaceX rockets, like Elon Musk wants to take people, but he is very overly, way over optimistic.
This will never, but this will never, like the SpinLaunch thing cannot launch people.
No. Let's
clear
that.
SpaceX will still have a place as far as the manned space mission shit goes.
Yeah, let's clear the air on that right now.
Person in this thing.
Let's just say it. Okay, so I don't know if it was this iteration, but they projected something like 16,000 or 20,000 G forces, and it takes about an hour for this thing to spin up. So you're getting high G forces for like a good portion of that, basically the whole time, but like, thousands and thousands of G forces for like 20, 30 minutes at least on the spin up. And so like the thing about G forces, I think we touched on this on a previous podcast, but like we can tolerate fairly high Gs. The highest ever, I think, is like 46 Gs by a human. 48, something like that, and but it was for a very brief period of time.
For a brief second, yeah.
If you sustain that for any period of time, your blood can't flow properly and all kinds of stuff. So you can, but yeah, that's far cry from thousands, tens of thousands of G forces.
This is specifically designed to launch cargo
stuff
or satellites.
Well, so they don't have a full working machine yet. They do have a couple prototypes that they've built, and they've got the patents to be able to make bigger versions, but the ones that they have now, like the one that's kind of hitting news, is 50 meters, so like 150 feet or so. And it's like the biggest span vacuum like ever, I guess. It's like record breaking, but it's also kind of a near vacuum. It's not perfect. It's not a 100% vacuum.
Just the fact that they were like, okay, let's get rid of the air so we have no friction.
Yeah, well, you know why, right? You know why they have to do that, right? Like, it's basically because if you spin something around in air, it's going to be creating so much shear force it's going to heat up the air around it, and also the shell of the like missile or projectile itself to pretty hot temperatures, like can melt steel like thousands of degrees.
I mean, air does have an amount of friction, and when you're talking about trying to get something to go that fast, you're creating a shit ton of heat. So
and so they draw out a good bit of that, but this is like a test. They still have a lot of tests to do, but the media seems to be over kind of hyping it, and really saying like, oh, look out, SpaceX. But they're kind of occupying two different niches. Basically, if we assume this thing ever does actually become a thing, which I'm a little bit skeptical of, or wary that this specific company will actually be the ones to be successful and profitable doing it. But like, if we assume that it does, like, well, for one thing, what do you think my biggest issue with it would be? We talked about it before.
Biggest issue with it?
Well, so I mentioned the niches. Basically, SpaceX would be bigger things for the most part, except when they do their like Starlink, like SpaceX is doing their Starlink satellites, which is a whole constellation of a bunch of little satellites. That's what this would be good for, is the small satellite range, which is in the like hundreds of pounds range rather than the tons, the thousands to tons range.
But you can launch multiple for a lot less is the idea.
Yeah. But there's, again, a lot of testing to be done. But let's assume, all skepticism aside, let's assume it does become a thing. My big issue is space junk. You know, that's already a problem. And if this facilitates, it's so tough because I'm like stuck between a rock and a hard place because I'm all for these kinds of things. We need these kinds of technologies to get things into space, and they will help with science in so many ways, but also it's just going to be putting more stuff into our atmosphere that we have to be aware of and could damage other things we put up there.
Now, these things, I mean, obviously this is not a working thing, but just from like the models and stuff that they've had or whatever, it's only supposed to launch it under its own kinetic energy or whatever from the shot into just space, right? Not outer space, just space.
Low Earth orbit is what they're aiming for.
They call it out of the atmosphere.
Right.
Well,
so then the shell
atmosphere
breaks off, and then a rocket actually will fire and take it the rest of the way.
It's not out of the atmosphere because the atmosphere has no absolute border. Like there are the different layers, the levels. So there's like the troposphere, then there's like the stratosphere, the mesosphere. It's basically
So we're going back to the Jeff Bezos argument of how many miles up is space.
Well, really how many miles up do you have to go to reasonably achieve orbit is what we're really talking about, because these things need to achieve orbit, and you need to be able to get to a certain altitude and a certain speed there. So that's
what they're aiming for, is to do that under the throwing it out the tube.
They want to throw it out the tube, and it gets ideally to like 60 some odd kilometers up in the air, which is about 2/3 of the way. It would take another like minute long burn of fuel to get the rest of the way up, and also get the speed, as I said. So get a little bit more altitude and a lot more speed to get out of the atmosphere. And it's a lot easier up there because the atmosphere is so much thinner. You don't have to draw a vacuum there. It's literally way thinner anyway, naturally. Some big issues with this, though, this technology, like they've only done 2. Well, go ahead.
Before you get into that, like, so the benefits of this would basically be what? Fuel costs, environmental stuff.
So like, as I previously mentioned, you could get a lot of small satellites, so it would be good. You could get like quick turnaround.
Right.
Some estimates are saying, like, I've seen like 4, 6, 8 hours. It would take hours probably to pump down the vacuum and also like reload the payload. But you could potentially do, dozens of satellites in a week, ideally, as opposed to like dozens in a year, which is what they're at now.
Okay, so you can launch a heck of a lot more in less time than with conventional rocket systems.
It's also a lot with less cost. It's a lot cheaper. That's the other thing. And also
that's the bigger thing. I mean, I don't think we're having I don't actually know, but I would assume that we're not having a problem launching the stuff that we need to launch.
Well, it gets up there, doesn't it?
Yeah. I'm like, I don't think like there's a need to send up 12 satellites in a month. Like,
some people would argue otherwise.
Yeah.
Like some people see a future where like every corporation, every semi-large corporation has its own satellite and stuff like that.
So we're gonna have like space traffic lights then?
People envision like crazy constellations of satellites. There's like estimates that like 1 in every 15 in the near future, like 100. I don't remember the estimates, honestly. Don't quote me on this, but like 1 in every 15 points of light in the sky could be a satellite. Isn't that kind of depressing?
Yeah,
like,
very.
Yeah, I don't know. It's like amazing.
Yeah, you just imagine like your kids like when you're raising yours and you're like, oh, look at the stars in the sky, and they're like, yeah, stars, okay, great. And then your kids are telling their kids eventually like, no son or no daughter, those are satellites.
I remember the day when I could see stars in our sky. Yeah.
Yeah. All the damn light pollution. So yeah.
Okay. Now we'll go to the and then of course there's got to be some environmental thing about not burning like tons of freaking whatever rocket fuel is actually comprised of.
Yeah,
I used to know what that was.
Well, they call it the rocket equation, where you need fuel for your fuel, and then you need fuel for your fuel your fuel, and then you need fuel. You get it. But like, it would definitely, or you know, it kind of depends on how you're getting your energy. First off, I need to throw that out there. Like we always need to consider where you're getting the electricity from. If it's from coal powered plants, it's not the
Obviously, it's not
greenest
great.
solution if it's using a whole bunch of energy. Even if it isn't an electrical solution to sending something up, and it does still use some fuel, and that will have its own issues that they need to work through. They haven't thrown an object up with fuel yet. Yeah.
So basically, we have one big, massive catapult.
Yeah.
Pretty much.
I think they have two built, and
Liberty statue size catapult.
Well, no, it's not that big yet. Right?
no, that one is the one.
Yeah, it's
that
150
the one that
feet,
works,
man.
Yeah,
That's-
the one
yeah.
they want to build is they have the one they want to build is like about 100 meters, but I looked into the patent a little bit and they use kind of funny language. I don't know if you want me to like read the excerpt from the patent.
Go for it.
Yeah,
you have
so
it handy.
yeah. In certain embodiments, a diameter of the circular mass accelerator structure may be approximately 100 meters. Although one skilled in the art will readily recognize that the diameter may be more or less than 100 meters, depending on particular applications. So the patent covers more or less than 100 meters.
Okay.
I
Let's
mean, I
make
guess
it-
for expandability, customization, I don't know.
Yeah. So yeah, should we get into like some of the
An odd way of learning, but yes, negatives.
negatives, the cons?
Yes.
Like where to even begin, really? Like I already mentioned space junk.
Actually viable.
Yeah, space
They
junk.
haven't tested this yet with actual like, yeah, they've run it, but I mean, they haven't actually like completed its task, so to speak.
Not at
No,
all. Like
I
not
mean,
even close.
They're years from that.
Yeah, probably. Yeah, I mean, not even probably. Like definitely, because I know you want to like do like kind of an year end capstone show where we like maybe do some predictions or something.
Yeah.
I'm just going to throw one out there that they're talking about testing in the next 6 to 8 months. I'm going to predict that they're going to have some issue. I'll even specify, I think they're probably going to have an issue with like their counterbalance catching mechanism, which we can talk about that if you want. That's yeah. Anyway, so yeah, some other cons, like people have argued that needing the vacuum to be better is arguably a thing. Like in one of the videos, the promotional videos, you can like see them, like little camera shot of the inside of, you can see the arm spinning around. It's like a camera on the wall, and you can hear the whooshing sound. I mean, they could put that in there if they really wanted to, but like if it's enough of a
not very
vacuum, there should be, yeah. I don't know how much of a vacuum they actually drew.
I'm actually surprised that they put a mic on that camera.
Or that
Why?
they had it like in the public facing video. They could obviously just not add the soundtrack to that, even if there was like, I understand wanting to keep track of sound, you know, sensor wise, wanting to know about your system.
Yeah, sure.
Yeah, but like,
But not feed it to the public. Why would you do that? But yeah.
but whatever.
Vacuums are tricky though. I mean, getting something airtight in an atmosphere environment is actually quite tough.
Especially if it's the biggest span ever. Yeah.
And
so
I've
like,
worked with,
Tupperware managed to do it, man.
what?
Tupperware managed to do it. It's another thing like
Not
airtight seal.
quite. Well, airtight is different from a
Yeah.
vacuum. The container of the vacuum does have to be airtight,
But
but
Space
also-
bags. Space bags.
so did y'all watch any videos about this? Did y'all see the
I didn't
video?
watch
Yeah,
any
I
videos,
saw the
just kinda-
promotional video where they're just demonstrating how it works. Yeah.
Yeah, and so you saw how it like the missile, the projectile like burst through the little like membrane over the tube as it exited. Like
temporary solution right
It-
now. Yeah.
exactly, temporary solution. So that's kind of one of the cons, is there's a piece of technology they haven't even developed yet, which is like the quick acting airlocks that they want to use.
Yeah.
Yeah.
What did they super complex.
Oh, they had a name for it. What was? I just read the bloody thing. Oh my god. I don't even know. He was talking about this. Oh yeah, a high-speed airlock. That was it.
Yeah. And so we need to develop that still. So
What? I don't even know what the hell that's like high-speed airlock. So a door that opens and closes really quickly?
I
Like,
guess
Well,
so.
it'd be like I imagine a series of doors where one on the bottom is open while it's vacuum and spinning, and as soon as the rocket
Right.
goes through, it closes, and the other one on top opens.
Yeah, but it would have to do that in the time that the
Yeah,
rocket is
very,
in the
very quickly.
chamber. Yes. So yeah. I mean, obviously an airlock would kind of define two doors, but yeah.
And that
I
and
would,
the
yeah, and I would imagine that you could put the first door, the bottom
Hold on,
door,
hold on,
closer
hold
to
on.
the
Hold
entry
on,
point of the
hold
rocket
up,
from
hold
the
up, hold up.
centrifuge chamber, and the other
Joe,
one at the end of the
Joe.
clutch.
we are interested in what you have to say, but
Yeah.
you totally androided out on us and sounded like a robot. So if you could go back a little bit so we can hear you.
Yeah.
Roger, Roger. So what I was saying is you could put the bottom airlock at the bottom of the tube close to the centrifuge, and then the other one up at the top, and that'll give you maximum time. But you know, timing is always going to be important there.
Yeah. I don't know.
But I mean, you're also talking about you don't want to make it like the biggest gun barrel ever to have this operate too. And I mean, I don't know, because
I'm glad you mentioned gun barrel because that leads me to the whole Project HARP thing, HARP, high altitude something or other. I didn't commit that to memory. High altitude research project. God damn, I could not remember that. Anyway, we can talk about that later. We can kind of dog ear that and come back to that though. They showed like fancy like 3D like models and stuff, and they never showed like the airlock specifically in any of them, like because they haven't developed it, you know. That's an engineering problem. Thankfully, we don't have to come up with the ideas for, but could be an issue.
well, somebody does.
Yes. Well, us three don't, but
Yeah.
we as a species
not?
do.
Come on, let's submit some plans. Let's go.
Yeah.
All right, Joe, you're already on it. I don't know if I have
Yeah,
any
let me
good
tell ya.
advice to give them. But like
No, we just need to figure out how to make it like, you know, catch the. We need to have an ejection port or whatever that's like a rifled gun barrel. That way you get the
but then you have to throw it into the barrel with like high precision.
yes. Well, they're already talking about high precision. Come on, it says high precision right in the article.
But
okay?
you got to have some play because like the tube is like way bigger than the payloads that they're sending through it, the projectiles. Like they don't want it to collide with anything, and that's gonna
like the barrel of a Glock, then just really loose. You know,
you really want to talk about guns, so maybe we should talk about Project HARP because it's basically that. It's basically a thing they were working on in like I think the 50s or 60s, and it
The
was
death laser. Yeah,
the death laser.
that's basically what it is, right?
It's not a laser though. It is a big cannon basically, but it uses like multiple, like a series of explosions along the barrel, I guess. And it also uses the projectile, and it is basically a ramjet or a scramjet, same name or two names for the same thing basically. Basically a thing that can kind of eat air and spit it out and gain power from it through like jet force propulsion, and it basically sends things out at 5,000 meters per second or whatever, like mini Mach. I forget how many Mach that is, whatever, but and also can send things like 100+ kilometers into space. Like basically they didn't get anything into orbit, but they did send objects that high successfully, so it's doable with a big gun. But it has its issues as well.
I was gonna say we're not putting that up in space and shooting down.
I mean, these things are huge. These are like, it would be like probably the size of ISS, I think. I don't know the exact
Honestly,
length.
to do damage from space, it's not really that hard. You don't really need that much material, even.
That's
I
fair.
mean, you launch something towards the Earth, the gravity does a lot of the rest.
That's a good point. You need basically at that point, you would just need something that doesn't burn up all the way on the way down, that can handle the full reentry. Then you just need
Pretty much.
mass. Yeah.
And you have a crater. Well, I mean, maybe not a crater, but you know what I mean.
Mm-hmm. But yeah, Project Harp. Pretty neat stuff. It also kind of reminds me of this one story that maybe y'all have heard of, this nuclear powered manhole. They like, some people claim is like the first object to have ever like entered orbit, is like one hypothesis. So there was one of the early tests in like the mid 1950s of like a nuclear test, and they call it a manhole cover. It was actually a borehole cover, BORE, and they put this nuclear bomb like 500 feet or something down into a borehole and covered it up with a borehole cover that was like 2,000 kilograms or something like that. And they predicted that it wouldn't last, so they decided to shine a camera on it, and thought it would be entertaining to see how fast it got shot up anyway. And the camera they were using, they only got it in one frame of their shot. They were still kind of able to estimate how fast it went, but they some people thought at the time and since then that it could have been the first object to enter orbit that was man-made, but like a year or two before Sputnik ever did. But then kind of more modern calculations have come out, and they think it actually maybe probably disintegrated, it vaporized on the way up from the frictional heating and all.
I would think that it probably wouldn't have survived that, but okay.
Yeah.
That is the thinking now. But that's
Yeah.
think about that. That's 2,000 pounds or 2,000 kilograms. I forget which one, but like a big old hunk of metal, not just a small manhole cover. Like it's actually bigger than that. And it vaporized.
Yeah.
It's just,
Yeah.
but,
Power.
and it didn't vaporize from the nuclear explosion. It got popped off by the nuclear explosion, and the atmosphere tore it to pieces, basically, the air.
Yeah.
Well, I mean, it would have had to have been moving fast enough to do it, but yeah.
Mm-hmm.
Wonder how fast it was going.
I don't
Very
remember
fast.
speed-wise that they estimated, but like the explosion ended up being, I think, 50,000 times more explosive or forceful than they thought it would be, which is a lot.
I mean, it had to have been moving pretty damn fast.
Yeah.
So to understand completely, this was like a chamber underground with a pipe going up and a bore cover sitting on top. They
It's not-
detonated the nuke underground.
It's not even, for the nuclear thing.
Like, what?
Yeah.
How did they do it exactly? Like, facility-wise, if you will, or
For the nuclear testing thing, I'm talking about two different things. It's not Project HARP. This is a different thing.
yeah, this borehole cover thing. How did they?
Yeah. I mean, it was a hole basically that they dug.
But they didn't like shoot a rocket into it, is what I'm saying. They detonated something at the bottom of a hole, used it like a barrel.
Yeah, they really were using it as an access point to put the thing way down in the earth so that it would have some stuff to stop it, basically, so it would, and also to measure the destruction of the earth and all. And maybe they were also maybe approximating, if it were to be dropped from something, how deep it might go from just the force of dropping, because they go into the ground.
Yeah.
I don't know. I'm not.
It depends on when they detonate, but
yeah, they can control time the detonation too. They can detonate them before they hit the ground and all that. Anyway, they were just throwing the thing. They didn't throw it down in the hole. They placed it down in the bottom of that borehole and then detonated it from down in the bottom of the borehole. No rocketry, nothing like that. They were just testing one of the very first, not the very first, but like one of the very first tests of a nuclear detonation.
Gotcha.
Yeah. It's often miscited as a manhole cover, which it's not really.
Yeah.
A
No,
lot more
it's not.
Yeah.
That's what everybody seems to call it. So
yeah, it's actually bigger than that though, which is neat. But yeah, SpinLaunch stuff again. So yeah, like we kind of talked about the high G forces that the stuff would have to take.
I
20,000.
think it's innovative what their approach to that is.
Yeah,
I mean, I give them credit for it. I don't know if it'll work, but
it's
at least they're trying to be proactive about something that they see as a problem in the future.
yeah, I agree. I think we need to be trying all our avenues possible to try to make things more efficient. You know,
For when we absolutely need to have, satellites like fireflies.
Well, I mean, that's again objective, subjective, if you will. But what my direct reference is into the components is what you were about to go into, right, Scott? Like what can last that G force and all of that. So that is the approach that I'm talking about, specifically their approach. And I figured you were about to talk about it, so that's why I didn't really say what it was.
no, yeah, exactly. You sensed that perfectly. I was going to talk about how they kind of talk about, they kind of hand wave and just say, yeah, we figured out already how to make the like stronger chassis or whatever they called it, scaffolding or whatever for the like satellites and stuff. But they would also need to probably design the satellites to be a little bit to cater to those high G's over a high period of time. They have tested electronics and things like that. They've tested, like, they called them action cameras. I assume that's like GoPros. They've tested like smartphones, and what else? I think I wrote telescope lenses, but a lot of things that are, have electronics and but a lot of them are really compact too. And they also didn't, from what I understand, they didn't send those up in a launch. They just spun them around in the centrifuge. And there's something to be said about once it goes from, the near vacuum to the atmosphere, that's going to cause some kind of disruptions that they'll have to take into account and have to learn about through all these testings they're going to do. But they kind of just say like, yeah, we've already figured that out. And I'm like, I don't know if you've really figured all that out. And we're going to have basically bespoke satellites probably to kind of be the form factor for this application now, which is feasible, but we haven't designed them for this.
How G-force would really affect electronics. I guess if it was more sensitive systems or sensor wise, because again, I mean, I don't even know what it takes to control a freaking satellite, like what controls their burn and their orbit correction stuff or whatever, and I have no idea. But I couldn't see how high G's over an extended period of time would really have an effect on electronics.
It's not just electronics. It's not just the electrical aspects of the electronics too. It's like the devices are made of materials, and if some of those get damaged in whatever way, from rattling or unexpected vibrations and any kind of not very well considered components, if they're not like properly dealt with to handle those high G's, they could fail, and they might not even be catastrophic to the launch, but they might not make it for whatever reason once they get up there, and they might have a higher failure rate as satellites. I don't know. We don't know.
The arm itself,
yeah,
that if anything was going to be a weak point, I mean, outside of the shell casing for the satellite itself, but I mean, time wise, they should be able to figure something out with that. But
yeah,
I mean, just the arm itself is probably the biggest thing with that, because again, like you were saying with the vibrations and stuff. But again, if it was even in a near vacuum, I mean, there shouldn't be a whole lot of vibration.
But the
except for
G's
maybe that last
themselves,
part,
though, can flex stuff, and it's basically like putting weight on top of it for a long period of time. So, I mean, think about a piece of glass. You set something heavy on top of it, it might break.
Yeah, and if they don't have things mounted properly and whatever engineering problems that we might not even be thinking of, probably won't be able to think of.
Think of how little G stuff go through right now. And yes, they go through vibration and all of that because it's a rocket in the atmosphere, and how sensitive they are as it is. And it's such a complicated dance to make them work and get through the process as it is now. So with adding a ton more G's, that's like, again, going from a 5-pound weight to a 5,000 pound weight. It's a huge difference.
Yep. Like there have been failures. I can't cite any directly, but I could almost assure you that there have been failures that have been attributed to like some of the G forces of launch or reentry in actual rocket launches, chemical rocket launches.
And remember this too, as you approach the speed of light, what happens to your mass? I mean, granted, we're not getting that fast, but the faster you spin something, the more force that is applied to that. So
Well,
even
that's
in near vacuum, it's still going to have
we're
resistance.
not getting really any significant relativistic effects from approaching the speed of light, though. It's not like gaining mass in that regard, but it is getting higher and higher forces. I mean,
Applied to it, yes.
yeah, like you could argue some gain in mass, but it would be so negligible that it's basically none. But they do have a part where they talk about like the arm, the materials in the patent, and they say materials advancements during the last 2 decades in ultra high tensile strength materials such as PBO, UHMPE, aramid, Kevlar, carbon fiber, carbon nanotubes, and combinations thereof have enabled launch vehicle tether construction at reasonable cost. So they just kind of throw out a bunch of materials. They're not saying they're going to make them with any one or all of those, but they're like, these materials show that we could make something that could withstand these forces, but who knows what they're actually going to use. But it's just interesting how they use the language in patents to kind of cover their bases like that. But another issue with the arm is the counterbalancing. First off, it has to be really well balanced, and with the like membrane rupturing, that's going to cause a rush in of atmosphere. So until they figure out the airlock thing, or even after that, they'd probably have to consider like the air rushing back in having some effect on the fast spinning arm. But also once that arm slings off that projectile, it's no longer in balance. And so they claim they can take care of that by having the counterbalance, having a part of it shoot off in the opposite direction. So as it's like spinning around and the projectile is getting shot up, they have the counterbalance of the arm gets shot into like this like special little thing. If you look up the prototype that they have, the like 1/3 size model, you'll see a little, yeah. Should we?
He did say, "Excuse me, I'll be right back."
Yeah. Should we just like pause for a second?
No, I did see that when they were talking about when it goes off or whatever, you're going to have something else that shoots out the other end that's just caught or whatever. That would keep the balance there.
Yeah, and I got no word of whether they actually used that mechanism in this test flight. They did like 1 or 2 test flights, and I don't know if they actually used that in this, or if they did. Even if they did, I wish Joe was here, but like they only did it at like 20%. This launch that they're talking about, there was only like 20% of the, like, I guess the input.
When you've got something moving like that, I mean, everything has to be, pretty tight on tolerances.
Yeah.
I mean, one little wiggle in the wrong way, and the whole thing is going to, well, I don't know if it'll come apart. I would assume that it would be catastrophic. Like one, what do you call it? Unaccounted for like vibration or something weird happens that just would shut the whole thing down.
Yeah. And like they haven't done any fuel tests yet from what I'm aware of, and they'll have to be able to have fuel systems that can kind of withstand that. I don't know if that would require special engineering or not, to have things that can withstand the high G's over a larger period of time, but possibly. And not even just that though, the changing in pressures, they'll have to like factor that into whatever their fuel they're using. It's just going to be a really complicated problem.
Well, see, that's the question, because eventually, I mean, the thing does have to have fuel for the second part of this, because it does need a rocket or a small burn to make it to where it's trying to get to, end game for it. But what do you call it? I would assume that there's just going to use standard rocket fuel, maybe like LOX or that highly volatile shit.
I don't think I saw anything that mentioned exactly what fuel they're planning to use, and their options are kind of open there. Some people even, I think, mentioned hydrogen, but that's always kind of an optimistic one to use hydrogen. I don't know. I really don't know. We'll have to keep an eye out over the next year and see what advancements they make, or see if this is just a big, nothing burger, or like so
There it is again.
Yeah.
So I think we talked about the term vaporware, right? When we talked about Star Citizen, maybe we didn't mention that term. That's something I learned.
You mentioned the term, but
yeah,
we didn't mention the term.
That's something I learned about recently, that I learned that term, the existence of the term vaporware. And yeah, so it's basically that kind of idea of like having software or hardware that's trying to get like a bunch of investors, but never quite delivers on the promises. Although Star Citizen has eventually delivered, right? It's now playable.
There is a playable game.
I think out of necessity.
But
like, we've sucked so much
They
money
want to
from
be
these
sued.
people, like we got to give them something.
but presumably kind of fell short of expectation and the hype, maybe.
They're still working on it.
Yeah, I was gonna say it's not done yet. So
Well, but to be fair, a game like that is never going to be stopped getting worked on, and you would kind of hope that, right?
Honestly, wouldn't you want your game to continuously be worked on? I mean, that's kind of my thought on the whole thing. Is like if they bill it like that, that's one thing. But if they bill it as a game that eventually will be done, this will be a packaged thing. You just invest and then you get it. That's one thing.
But they presented a thing, and they did not give us that thing. They gave us part of a thing. And the term is, oh well, we're still working on it. Well, you've been working on it for a very long time. So but hey, people can spend their money however they want to spend their money. I certainly do what I want with mine. So I'm like, whatever. If that's your thing, go for it. Have fun. But yeah, that was gonna be my closing on this. Was, is this gonna be like, I mean, I don't know who's paying for this. I mean, assuming the company has investors and this and that and whatever, but it's going to be a whole lot of money to go nowhere.
Yeah, exactly.
I would like to see them actually be successful. I'm not saying they will be. I'm not saying I think they will be. I'm just saying I would like to see them be successful.
We'll get something out of what they're working on. I mean, we'll learn stuff. We'll get somewhere. Like Scott said before, it's not even sure if like this technology will probably happen at some point, but whether it's this company that brings it, full circle or not, who knows? But we're definitely going to learn something from this. So if nothing else,
important.
Hopefully nobody dies though.
Yeah, I already said we can't send people off with this.
Well, but there's still people around the facility, and it's a big spinny thing that can have a lot of inertia and could just spin away.
Meant to have a lot of inertia. Yeah, it's designed to do that.
I mean, there's danger in everything. I mean,
yeah. There's danger with chemical rocket launches, and that didn't shy us away too much.
We put people on.
I was gonna say, I was all like, how do you think the first astronauts felt like? Oh, we're just gonna sit you in this thing and strap you to a freaking rocket and send you into space, like. Okay.
You had to have balls of steel, man. Like seriously, sit on that much fuel and get launched into space.
So like if you believe that we landed on the moon, then you have to believe that we didn't get there by astronauts and other people being cowards. So
and if you don't believe that we landed on the moon, you can get the hell out.
Must be a flat earther.
Yeah.
I don't want to be exclusive. I mean
okay, yeah, flat earthers and lunar landing denialists, you can stay, but we're gonna corrupt you and make you believe in it eventually. That's my goal.
Anyway, that's it for Technically Incorrect. Thanks for joining us, everybody. Don't forget to like, comment, and subscribe. And considering we've been on a little bit more of a kick now on as far as posting at least every week. but still kind of random, whatever. We might miss a week, whatever. So do hit the alert button. So in case you do miss it. But anyway, adios.
Bye.
Okay, cool.